So this is Newton, section 4.2. Has two parts to it: add and subtract rational expressions and simplify complex rational expressions. So I'm going to do just the first one on this video, and then I'll make a separate video for the next one. So let's do a little bit remembering about just how to add fractions together. So remember, if you have two fractions that look something like a over b plus c over d, you need a common denominator, so you would multiply the first fraction by d over d and the second fraction by b over b, and you'd get ad plus bc over db. And nothing can be canceled here because of the adding in the top. Okay, so then let's talk about what if you have numbers. And I want to just do a little thinking and talking about what if my denominators were 8 and 12. And I wanted to have a common denominator that was the smallest common denominator. So clearly, if I multiply 8 and 12 together, I get a number that they will both divide evenly into. So this is definitely a common multiple, but I want the smallest possible common multiple. So the way we can find that is to factor 8, which is 2 times 4, and 4 is 2 times 2. So if I factor 8 into prime factors, it's 2 times 2 times 2. Then let's factor 12 is 2 times 6, and 6 is 2 times 3. So 12 is 2 times 2 times 3. Well, if I write the set of factors of 8 as a set, and then I look at the factors of 12, I see they have an overlap. They have a 4 in common. So 8 can be written as 4 times 2, and 12 can be written as 4 times 3. So I don't need to count those factors of 2 twice when I'm trying to find the smallest common multiple. It's going to be 2 times 2 times 2 times 3, or 24. So that's a lot smaller, and you want the smallest one just to make your work a lot easier. Okay, so that's the least common multiple, or if you're working with fractions, the least common denominator, the lowest common denominator. So then I want to talk about the other thing that we often want to find with two numbers is what is their greatest common factor? Well, in this case, the greatest common factor is this overlap, the intersection of the two sets, which is 4. So 4 is the biggest number that divides evenly into 8 and 12. And 24 is the smallest number that both 8 and 12 will divide into evenly. So when we're talking about polynomials, we might have something like an x minus 2 and an x plus 1, and an x minus 2 and an x minus 3. Well, the LCD is the x minus 2, but you don't duplicate that. And then you'd need the x plus 1 and the x minus 3. So this would be your LCD. And then remember, if you have something like 3 and 6, that 6 is the least common multiple because that's the smallest number both will divide into evenly. Okay, so let's go back to this problem with x's and y's. And I can see that my first denominator has factors of 2 and x. My next denominator has a factor of 2 and another factor of 2 and a factor of a y. So my LCD is going to be 4xy. So my first fraction, I need an additional factor of a 2 and a y, and the only way I can do that legally is to multiply the numerator and the denominator by 2y, because then that's equal to 1, and I can multiply by 1 anytime I want without changing anything. So then I have x over 4y, and I need x over x in order to have the common denominator. So then I'd have 4y plus x squared over the common denominator of 4xy, and that would be my final answer. Okay, so let's look at the next one. Let's factor this denominator. I'll have x minus 2, x minus 1. So this is a case like the 6 and the 3, where the x minus 2 divides evenly into the other denominator. So the first fraction, I don't need anything in order to have the common denominator. But the second fraction, I'm going to need x minus 1 over x minus 1. So hopefully you've developed some strategy for doing this distribute. Like some people put plus and a minus to remind themselves they're distributing -2. So I have 4 plus -2x plus 2 over my denominator, x minus 2, x minus 1. So I'd have -2x plus 6 over x minus 2, x minus 1. And then you should at least check to see if there are any matching factors in the numerator and denominator. So I'm going to factor out the -2 and have x minus 3 over that denominator, and nothing is going to cancel here. So that's my final answer. And I prefer factored. Either one is acceptable. So the purple answer is fine. But you do need to at least check and see if they have any common factors. Okay, and then this third one, we have nothing in common. So the first guy is going to have to get multiplied by the entire second denominator. And the second guy is going to have to be multiplied by the entire first denominator. So I'm going to have 8y plus 8 when I distribute, plus 4x minus 8 over x minus 2, y plus 1. So yay, the 8's cancel. And I have 4x plus 8y over x minus 2, y plus 1. And then I would factor out the 4 just to make sure there isn't any matching factor. So I'd have 4 times x plus 2y over my denominator. Okay, then D, let's start by seeing if we can factor this trinomial. And the second denominator divides evenly into that denominator. So again, this is like having 6 and 3 as your denominators. So the first denominator, we don't need to do anything. It already has the common denominator. Minus 3 over x plus 5. But we need x minus 3 over x minus 3 to get our common denominator. And again, if it's helpful, put the minus up here with the 3 so you can remember that you're distributing a -3, if that's helpful for you. So I'm going to have 7 plus -3x plus 9 over my common denominator. So I have -3x plus 16 over my denominator. Okay, so let me know if you have any questions about that.